So we're going to be talking about array lists and other abstract data types, other containers for holding multiple pieces of data. One that you may have heard about in other programming classes like Python is called a dictionary, but Java calls it a hash map. Same idea. And then there's also stacks and queues. All three of those are useful and tailored towards different ideas. So let's get the PowerPoint out. I thought I'd already downloaded it, but I got distracted. Let's get it. I can have the rest of my screen, please. Thanks. All right. So the Java Collections Framework has a whole bunch of different types of classes for holding data, sets of data in different ways. Java Collections Framework. If we look it up, we're going to see a whole bunch of them. Do we need to know this many of them? No, we do not need to know this many of them. We will get a fair representation of them. We will learn about array lists. Related to the array list is something called a vector. The stack is an implementation of a vector. And there's something called a priority queue. So we're going to be talking about array lists, stacks, and priority queues. And then later on, we're going to be blipping over to, I'm not seeing it on here, the hash map. Okay, fine, it's in a different one. Anyways, so you can see that there's a whole bunch of collections, all tailored towards specific circumstances. A stack, for example, is something where you insert things on one end and then you extract things on the other. No, that's not right. You insert things on one end and then you take them back off the same end. Whereas a queue, you insert things on one end and you grab them out of the other. Yep. It's like slamming something down and then later on you pop it back up. Array lists, on the other hand, are just random access. You're not pulling off the, the ends as you're supposed to be limited to doing with a stack and a queue. The advantage of these data structures is that they grow and shrink. Once you declare an array, it's a fixed length, meaning that if you wanted to add items to it, you'd have to allocate a brand new array that was larger, and then you'd have to manually copy all those items into it, which is a real pain. Or if you want to delete something in it, in the middle of an array, you're either left with a gap or you have to create a new array that's smaller and copy all the elements into it. Used to be in programming classes you would learn how to create your own array lists, linked lists, stuff like that. Fortunately, nowadays we get to use the classes that other people have already written. So the array list provides a basic functionality of a standard array and additional capabilities. So the basic functionality gives you an ordered collection of values. Ordered meaning, element 0, element 1, element 2, element 3. But you don't access the elements with the square braces. But you do have an index. I want the first element at 0. I want the second element at 1, and so on. But what's cool about it is that it grows and shrinks dynamically by inserting and deleting elements at any specified location. So the way you create one, well, you have to have your import. We really don't need that. You have to have your import statement. And then when you create it, it seems like some books use angle braces to indicate, some optional thing that you're supposed to type. Well, in this case, you actually have to include the angle braces in your definition in order to get it to work. So array list and then element type, and then the name of the array list is equal to new array list, and then you put that there. Notice that we're not putting a number in there like we did with arrays. We're not saying I want an array list that's 10 long. Instead, we're just saying make me an array list. It's going to be an empty array list, and then we're going to start putting things into it. So for example, we can have an array list of strings. Array list string ALS, I don't know, equals new array list string, and then parentheses in parentheses. Now you don't need this. It assumes this string here based on that one. So we can eliminate that. But you got to keep the angle braces. That's just part of the syntax. And now we need these parentheses there, whereas we didn't need them with arrays because we're calling a constructor. Since the array list is actually a class, anytime we created a new object, right, you know, point p is equal to new point, right, we had to put the parentheses after it. Same deal. Except we didn't have to put angle, you know, we didn't have to do that, but it's because it was not capable of carrying different types of data. This is capable of carrying any kind of data that we can stick there. Now, what do I mean any kind of data that we can stick there? It can be any reference type. It can be any class. It cannot be a primitive data type. So, array lists and the other collections and the other items in the collection framework can only work, yeah, why don't I retype that? Can only work on reference types, classes, not primitive data types. So here's what you cannot do. Array list int. ALI for array list events equals new array list. Why? Because that's a primitive data type. It's not a reference data type. It would not be able to manage the references in the way that it needs to. Because just like an array, is a list of references, so is an array list. You can get around that, though, by using what are known as the wrapper classes. The wrapper classes are the classes that perform the similar functionalities of primitive data types, but then more so. So you would want to do this. Array list, capital I, integer, ALI equals new array list. And the wrapper classes, through some magic that I haven't figured out how they do it, interchange directly with the primitive data types in a way that I haven't seen in Java in any other context. C++ makes it easy to do that, but this language does not. And what do I mean by that? If you do this, integer x is equal to 3, magically this 3 gets copied into that x. Right? We didn't have to do this. We didn't have to say integer x equals new integer and then set it, right? X.set. Magic. Don't know how they did it. Ought to learn. Right? And then float f is equal to 3.5. Right? That is good news because when we start adding elements to the array list of integers, we don't have to add them as the integer class. We don't have to create integer objects to stuff in there. We can just stuff in an int and we're good to go. Or we can stuff in a float and we're good to go. It will create the integer object or the float with a capital F object and put it in there. Meaning that for all intents and purposes, it's almost transparent to us that we're having to use integer with a capital I rather than int with a lowercase I. I better put a comment to the effect that this does not work. Int is a primitive. So the ability to to encapsulate automatically a literal into an object and have it be created like that is known as boxing. Creating an object by assigning a value to it. Wrapper classes are the only ones I've ever seen do that. So the 3 gets boxed into an integer object by doing that. And then unboxing is just doing the opposite. If I do this, int I is equal to x, right? Well, x was an integer object. I did not have to call x.get to extract it. I did not have to call a getter. It is magically turned into an int as a cross equal sign. That's called unboxing. So unboxing is extracting a value by, I'm not coming up with a great definition for it, without calling its .get. So boxing it is creating an object by assigning a value to it without calling .set or creating, new. In the meantime, I've been trying to get to the point where I can actually create our samples. It kind of looks like we're on H2. I'm not sure if we know enough to do the homework assignment based on H1. We will look. But anyways, let's make a project called H2. And we may as well create an array list of strings. I'm going to take the package statement out because I don't like package statements. I have to remove it every time I grade them anyways. Now that I've created it, I have to move it to the correct folder. So I'm just going to click on the arrow on line 1 and do move to correct folder. I'm going to delete a whole bunch of comments. Alright, now I'm feeling good. So, array list angle string capital S end angle ALS equals new array list angle end angle parentheses end parentheses. It doesn't know what array list is, so we have to add the import. Good old NetBeans lets us do that. Add import for java.util.createList. As always, I encourage you to never choose create class unless you absolutely know that that's what you want to do. You'll be very intentionally doing something when you do that. Don't do it just to make an error go away. It'll give you a bigger error that's much more difficult to fix. Alright, now we can add some items to our array list. ALS dot add. Let's add some things to it. Alice. ALS dot add. Parentheses quote. Bob. And then one more. ALS dot add. Parentheses quote. Carol. ALS dot add. Parentheses quote. Carol. End quote, in parentheses, semicolon. Why are you giving me a warning here? The collection is only added to, never read. Okay, yeah, fine. No way. It's always interesting to click their little suggestion and see what it's doing. This would check to see whether the add was successful. I've never seen an add fail, so that's pointless. All right. Now we can traverse the array list. We can do it with a for each loop. For, parentheses, string s, colon, ALS, for every string s in our array list. System.out.println, parentheses, s. And what's your... Here's my favorite correction that it offers. We have this nice, clean, easy to understand code, and then it becomes that. That's pretty neat. I haven't quite learned how to do that, so I'm going to undo that. That's actually cleaner than it used to look. It looks like in Java 9 that they've made that syntax a little bit cleaner. I can actually almost comprehend that one. But undo it. Now when I run it, it's going to print out the names Alice, Bob, and Carol. So what's the big deal? The big deal is that we did not have to set a size for the array list. When we are not having to keep track of them by their index order. We did not have to say element 0 is Alice, element 1 is Bob, and element 2 is Carol. Even better, we can insert things into the middle of the array list. What if we have some new guy, David, but he wants to be standing between Alice and Bob? Yeah, go back to the end of the line, dude. ALS.add, parentheses. We're going to give him an index number. We want this new element to be the second element in the list, because Alice is the first, and since she's index 0 and Bob is 1, we want this one to be element 1, comma, David, end quote. Now when we print them out, we're going to see Alice, David, Bob, and Carol. We were able to add insert into the middle of the list, which would be quite a trick to do with arrays. Once you learn about array lists, you almost never use arrays ever again. Why do you spend so much time on it? You may wind up programming in a language where you don't have easy access to array lists. You have to have the concept. Python doesn't even have arrays. The only thing it supports are array lists. We just treat them like they're arrays for the purpose of learning the language. You can remove something from the list. ALS dot, no, excuse me, not ASL. ALS dot clear would wipe out the entire list. We don't want to do that. We can use set to change the value. We can remove by index, or we can remove by object. Let's remove by index. We're really ticked at David for cutting, so we're going to remove him. ALS.remove index 1, and then print him out again. Now to print him out again, I'm just going to do, can I do this? Can I do system.out.println parentheses ALS.toString? Is that going to make me a nice pretty version of it? It certainly didn't for arrays. It might for array lists. Yeah, there's our array list. What it's doing behind the scenes is it's using some variant of what's known as a linked list. Yeah, we have to have the import java.util.ArrayList up at the top. Let me wander around and make sure everybody's where they want to be. All the elements from the old one into it. Array, and then capital L, list, parentheses, excuse me, angle, string, end angle, AL2 equals new array, capital L, list, angle, end angle, and inside the parentheses I'm going to pass in my first array list, ALS. That clones the original array list so that AL2 is now a copy of it, which is nice because then we can make modifications to AL2 without it changing ALS or vice versa.
Wait, so you said that if you change ALS with the first one, it also applies to AL2?
No, that's like if you have two arrays pointing to the same space. This is actually a brand new copy of it, so changes to one do not affect the other. We could prove that. Let's change ALS dot remove parentheses 0 in parentheses, but then print out AL2, right? Just like we did here. I'm going to be lazy and copy and paste, but I'm going to change ALS dot toString to AL2 dot toString. So my second print line, I wanted it to be AL2 because I removed something from the original playlist after making a copy of it.
I just want to make sure I didn't miss here.
So I did delete, I deleted the first element. If I printed out ALS the same way, it would be missing its first element. What happens if we take out the call to toString? I think we've established in prior classes that calling toString is superfluous because if you're passing the object to something that's expecting a string, it will call toString for us automatically. Another one of the mysteries of Java, how they happen to make that one method that something that gets called automatically. And it works just as well. Adding elements to an ArrayList object. You just call add. Now we're passing in strings, which are the easiest elements to create, right? You just use the equal sign and quotes and it creates it for us. If we were using an array list of another type of object, we'd actually have to create the object before we added it. But the primitives, the wrapper classes, like integer and float and double and things like that, all with a capital A, capital double and capital, F, things like that, will allow us to create them just by their value. But if we have a class, we will need to create an object of that type before we insert it. So let's define a class. And we're going to be absolutely horrible and define it right here in the middle of this class. This is the worst possible thing to do. You should put this in its own file. And if you're not going to put it in its own file, you should at least not embed it inside another method. Class data. It's going to have two pieces of data. String A, comma B. And we're going to make a constructor for it. So public, void, nope, they don't even have return types. A constructor is something that has the same name but no return type. Public data, parentheses, and what kind of arguments does it receive? It takes a string A and a string B, close parentheses, and then open curly brace, this dot A equals A, semicolon, this dot B equals B. I'm going to compile it just to make sure I don't have any horrible syntax errors popping out. And I should have been adding comments as to what we were actually proving here. I didn't really do that. I will on this line. Let's make a copy of the ALS list and store the result in AL2. All right, now we can make an array list of that type. Array list, angle, data, close angle. ALD for array list of data equals new array with a capital A, list with a capital L, angle, close angle, parentheses, close parentheses, semicolon. Now I'm going to make a new data object and store it in there. Data D1, just in case I want to make a D2 and a D3, equals new data, but we're going to take advantage of our constructor. And as a matter of fact, since we added a parameterized constructor, we cannot even use a default constructor anymore unless we go back and edit that. And my pieces of data are going to be just somebody's first and last name, Joe. So new data, parentheses, quote, Joe, end quote, comma, beginning quote, Roberts, end quote, in parentheses, there. And now we can add that to our array list. So ALD.add, parentheses, D1. Close parentheses. Really would be nice if we had a toString method on this object so that it'd be easy to print. And it'd be so easy to do, why don't we do it? I'm going to go back up here and add a toString method. So make sure you get it in the exact right place. Maybe I'll even put it above the public method to make it even easier to spot. We should have two closing curly braces at the end of our class. Public string, capital S, lowercase 2, T-O, uppercase S, string, parentheses, close parentheses. And we're just going to return, in the middle of the curly braces, return A plus quote, space, end quote, plus B. I'm not going to make it pretty with string.format or anything. Now, what are you complaining about, Mr. Warning? Add the override annotation. Not a bad idea. This is an override of something from the object class. So I clicked on the error and I made it go away by clicking add. We'll talk about what that does at a later point. I know I've mentioned it before as well. Alrighty, now I'm going to do this in the absolute wrong way. I'm going to make another object. No, I'm not. I'm going to forget that I need to make another object, and I'm going to do d1.a equals, and I'm going to set it equal to something else. Sam, quote, Sam, quote, semicolon. And d1.b equals, quote, whatever. Samson, end quote, semicolon. And now add in d1 again. ALD.add, parentheses, d1 in parentheses. Now we're going to use a for each loop to print it out. So, for parentheses, our data type is called data, so data space, why not D, since we didn't use D, data space D colon ALD system.out.println parentheses D. And that is absolutely what I did not want to happen, right? I thought I was adding two different pieces of data. I thought I was adding Joe Roberts followed by Sam Sampson. However, what we did is we didn't create a new object. We just reassigned the values of the old one. And so now we have two references in the list that are pointing to the same piece of memory, and we change it for one and it changes it for the other. We should have created a new object to hold this data. So we're going to, if we really insisted on using the same name, we could do that. D1 equals new, capital D, data, parentheses. And since I did not add a default constructor, I have to pass those pieces of data in. We could go back and add a default constructor, but instead I'm going to pass in quote Sam, end quote, comma, quote Samson, end quote, close parentheses, semicolon. I'm going to delete those two lines. At least I'm going to comment them out at this point. So I changed this line, or I added that line. I just inserted this line. And then I commented these two lines out. And the rest of the code remained the same. Let's run it. All right, and we do actually have two separate objects now in the list with two different pieces of data, which is a very, very good thing. This is not the only way to extract data from a list. You can also call .get and get that object. Rather than just step through it with a for loop, we want to pull out the second item from a list, we can do that. Let me make sure that I haven't lost anybody yet. So let's do that. I'm going to make a new reference. I could reuse D1, but why keep reusing the same one? Data D2 equals, and by the way, I chose a bad variable name. ALD, I never want to use lowercase l when it can be confused with an uppercase I or a 1, and I did. But anyways, ALD dot get parentheses element 0. And that's the one with Joe Roberts. So if I print out D2 now, it's going to print out Joe Roberts. Or if I print out D2.string. System.out.printl parentheses D2. I could add .toString, but it's superfluous, right? So I'm not gonna. And so I printed out Joe Roberts because that was the object that it retrieved the reference to. What happens if we had put a 1 there? Prints out Sam Sampson, because that's the second object in the list. What if we put a 2 there? We're not going to like the results. It blows up. Index out of bounds exception. You can't retrieve a negative index, and you can't retrieve a value that's passing into the index. So just like an array, you can go from 0 to n minus 1, where n is the length, right? So if you've got 10 elements, you can go 0 through 9 as the index values. All right, we have that object. We could remove it from the list. This is removing it by object rather than removing it by index. ALD dot remove parentheses D2, like that. Close parentheses. And now if we printed out the list, we would only see Joe Roberts, and not the other one. I need to fix that get to because it was an exception, right? I think I'll change it just back to 0. But I'm going to add some comments here. Get first element, not forest. Print first element. And then remove first element. So now if we print the list, did we not print it out earlier? I'm not seeing us printed out the list in this fashion. So system.out.println and just print out ALD. System.out.printl and parentheses ALD. And we're going to see that this list now only has one element, and the first element is going to be gone from it. Am I usually going to recommend that you reuse the same variable name? Well, yeah, if you're inside a loop, there's no reason not to, right? You don't need to make a separate reference variable for every new piece of data you add. Just create one variable and reuse it over and over by calling new. But don't do this. Don't try to reuse it over and over just by changing its members. If you're inserting them into a list, you have to create a new object so that you have a new address that you can stick in there. So the Java API stands for Application Programming Interface. It's a huge library of pre-built Java classes. It's been added since in the last 23 years, whenever Java was invented. We don't need to know the internals, we just need to know how to use them. I don't know how the ArrayList works. I have some vague ideas. I just know how to access them, in which case we use their public methods. To use a method, we have to know what type of arguments to pass to it and what kind of value it returns. So the methods API shows the method's parameters and return type. If I was real curious about what an array list could do, I could highlight it, right click, show Java doc, and it would show me all about it. Remove all. That would nuke everything from it. What's the difference between remove all and clear? I don't know, I'd have to read them more carefully. How about if we wanted to find a particular object in it? I bet there's a way to do that. There would need to be. Right? not jumping out at me.
How do you use set?
Set. Set's a good one. I forgot to do set. Set replaces an element rather than remove it or add it. Remember our arrays of names up here? We had somebody named Alice. Let's change that one. So maybe, I don't know, I scrolled up and I found the place where we were letting David cut in line. ALS.set, parentheses, at element 0, so I'm going to leave it as comma 0, or excuse me, ALS set, parentheses, 0, comma, and then we're going to put some new date. Abby. End quote, parentheses, semicolon. Now the name Alice is completely gone because we replaced it. In the array. That's just like doing this, just like when you had an array. Don't type this, right? Right, like that. In the C++ programming language, where you're allowed to override operators, if you had an array list, you really could do that. You could access it via, but Java took out, never implemented that on purpose. So that we use get and we use set to mean the same things as the angle braces to access them. So I'm going to make some comments to that effect. To set an element of an array, how am I going to word this most succinctly? Array subscript I equals value. Array list dot set parentheses I in parentheses equals value. That's how you set them, along with the semicolons. To retrieve a value, to get a value, array subscript I, value equals array subscript I, like that. Or value equals array list dot get at index I, parentheses I in parentheses. And we've also talked about dot add, which has two uses, either to append or insert. We've talked about dot remove, which removes either by index or by value, by object. If you are going to dot add or dot remove by index, no. If you're going to do dot add, you can like either not specify the position, like that, dot add parentheses quote Bob, end quote in parentheses, or you can specify its new add index value. To insert into the beginning of the list, you would use index 0. Dot add parentheses 0, comma, quote Bob, end quote in parentheses, inserts into the beginning of the list. I'm going to blip over momentarily to the homework that was supposed to follow this. See if we think we're ready for it. I would like for us to be. We've learned about two-dimensional arrays. We've learned about array lists. I think I'm going to set a longer due date than normal on this one. It's going to wind up being a staggering 3 weeks because of spring break. All right. Well, that's not nearly as hard as I thought it was going to be. Poop. Okay. This is the easy one. And I'm not going to even assign B, the two-dimensional array. We've talked about two-dimensional arrays. We've printed them out in our homework, right? People who've done the homework. Okay. So, the homework is going to be write a program that allows you to enter a series of numbers, ints. Every time a new number is entered, add it to an array list. Let the user stop by entering a -1, so it's just going to be a loop. When the data entry is done, display the contents using a for loop, or for each. Also, calculate and display the sum and the average. So you're going to use loops just like we did with arrays. Remember that you can't store ints into an array list. You have to use the integer class. So you can't do that. You can do that. Let's go ahead and write a little bit of code that will calculate the sum of an array list. Did I already have an array list of ints somewhere up here? No, I'm not spotting it. I'm going to declare it as floats, though. Alf. Array, capital A, list, capital L, space, ALF. I forgot something. I forgot the angles. Array list, angle, double, end angle. Double's got a D. And instead of calling it alf, I'm going to call it ALD, A-L-D, because it's an array list of doubles. Equals new, array list, capital A, capital L, two angles, two parentheses. And I've done something wrong. Oh, I'd already defined one called ALD. Okay, fine, ALF. I'm wondering if I can make an array list this easily. And I'm just going to add some values to it. ALF.add parentheses, type a number, 303 in parentheses, and then copy and paste that a few times. You know, but change the numbers. I seem to be getting errors. And the error is that I'm trying to pass integers in, but it wanted floats. Excuse me. All right, change them all to floats. Add 0.0 or 0.1 or anything to them. Okay. So I've created an array list called ALF. I've added 5 values to it, and I want to sum them. It's just going to be a for each loop. Or we could use an index-based loop, but for each loops are so much easier to write. That's what I want to do. For, parentheses. Oh, I'm going to need a value to hold the total. So above that, double space total. I could have used a capital D double. It doesn't matter, really. I'm going to use lowercase d because I don't have a good strong reason for using the uppercase D. For, okay, double space D colon ALF. Close parentheses, total plus equals D, semicolon. I forgot to initialize total, excuse me. You're going to need to go back up to the line where we declared total and give it a value of 0. Double total equals 0. How do you calculate the average? You need to divide the total by the number of elements in it. Fortunately, we have a way to do that. Unfortunately, it's not dot length like it is for an array. So double space average, or just AVG for ease of typing, equals total slash ALF dot, it's not length, it's size. So ALF dot size, open parentheses, close parentheses, semicolon. And I could print that out, but I'm absolutely sure it works. if you care. Print out the total and print out the average and print out the values as you go along, right? We could expand this, right, so that we were printing them out as we calculated the total. I'm going to blip away just for a second so that I can hop over here. Alright, there is a Dropbox H so that you can upload when you want. I'm going to leave this up on the screen for a minute more so that anybody who I left behind typing has a chance to finish typing. While I do that, I'm going to talk about the difference between this and a stack. A stack, you do not insert into the middle. All you can do is add to it. And we would really like for the stack class to have a dot push and a dot pop method, because that's the terminology that everybody in the industry uses. Howsoever, don't necessarily type this. A stack, parentheses, floats, well, it looks like it uses add, but hey, okay, fortunately it does use pop and push. My mistake, I was thinking of something else. Thinking of the terms for NQ and DQ for a queue. So, notice that when we created the stack, and we're going to talk about stacks more next time, the syntax was almost exactly the same as the array list, right? Except different data type. Stack, float, st equals new stack, rather than array list, float, st equals new array list. Same for anything else in the collections class. Going to make a hash map, a dictionary, it's going to be the same thing. Except the dictionary is going to require two pieces of data separated by a comma in there, inside the angles rather than one. When you're ready to start adding data to your stack, you use st.push. And I'm going to add a floating point number. There we go, like that. And it didn't like that, so I'm not going to talk about stacks anymore until I'm absolutely ready to. Okay, just because I made it a stack of floats rather than doubles, I'm going to make that go bye-bye. One of the coolness about the generics, about the collections classes, is that the same syntax will iterate through any of them. We can use a for each loop like that to rip through any of them. Doesn't matter what kind it is, whether it's a hash map. Yeah. There are more specialized ways of pulling things out, right? Like this one uses .get, and maybe we shouldn't be using .get to pull out of the middle of a stack, but it probably does support the .get method. You just have to kind of make an agreement with yourself that, no, I'm not going to be pulling things out of the middle of the stack because you're supposed to be adding things on and removing them from the same end. I think that that's about enough. We have seen how to call get. Get requires an index. We've learned how to use set. When you call set, it requires an index and an element. And then there are methods like add, which we've talked about. Clear removes it all. There's the one I was looking for, that the one that will actually search the array list for a specific value. It's called index of. You can also check to see if the array list is empty. Honestly, I would just call .size and check to see if the size is 0, right? That way I don't have to remember an extra method to check to see if it's empty. You can remove by its index value, and you can get its size. Something is slightly bugging me. I don't know. No, I think it's okay. I think it's okay. I think it's okay. I'm going to check it. Array list subscript integer AAA equals new array list. And we are done for today. I just want to make absolutely sure that adding to an array list is as easy as doing something like that. Okay. It does support the automatic boxing, the conversion of that integer into the integer object. Wanted to make sure that there wasn't a problem like that, because we saw when we were adding here that if we did not explicitly make it a floating point type, it yelled at us. It would not box an integer to fit into a double. Well, then we're not going to do that. We're not going to add an integer into a double. All right. We have a few minutes we could hang out, but I'm going to end the lecture here, and then if we have questions over homework or something like that, then we can talk about it while videos are uploading and stuff. Any questions?